Hey, good evening, everyone. I hope you are doing great. We are about to start week number 3's content. Please just make sure this add class code could work. Would you please just give me a feedback and say if it works or not? Thank you. Okay, thank you very much. So if you can see the screen that I have already shared, we are about to start our hands-on. Tomorrow, we are going to continue in the lab working on Colab. We try to cover as best as we can the most useful content that make you ready for your assignment number 1. But before anything, just consider that the concept that we talk in this section, we will extensively discuss in future weeks. But we need to start from somewhere. And everything that you see here will extensively elaborated on in future weeks. The first thing is, it says, let's look at the concrete example of a neural network that uses the Python library Keras, because the MNIST dataset is something that everybody uses to start the machine learning and deep learning concept with. Keras was kind enough to include it, so you don't need to enter it manually or just have the CSV file, for example, or something like that. So you just need to import the Keras library. As we have already talked, every picture that we have contains 28 by 28 pixel handwritten digits, and we need to categorize them into 10 different classes from 0 all the way to 9, right? Guys, if the voice is clear and you can hear everything fine till this moment, please type 2. Thank you very much. I have changed the setting, the hardware and the whole things. So I would ask you for more confirmation during the session to make sure that everything works fine with the new setting that we have. The number of samples that we have for the training part is 60,000, and the test part contains 10,000 images. As you see that it is mentioned, it's a kind of hello world in the deep learning environment. And well, this is one of the quiz questions, so I read it carefully. This is something that people confuse themselves because they are pretty close to each other. Categories, classification, labels, what are the difference between them? In machine learning, a category in a classification problem is called a class. So when you talk about the categories that we have, like class 0, class 1, class 2, means we have hundreds or thousands of samples that they are in class 1. Is it clear? So when we talk about classification, we talk about different classes that we have. It's like drawer, that you put all the pictures, all the handwritten digits that they belong to that class into that drawer. So imagine that the label on that drawer is 0. So you're going to put all the handwritten digits that they are in that class in that drawer. So that is what we call class. But data points are called samples. What does it mean? Means every single record that you have, they are one sample. We started machine learning previous semester saying apple and orange. Every single row that we had was a sample. It's like a record in database, a row in Excel, right? And now look at this one. The class associated with a specific sample. The class associated with a specific sample is called a label. So label is something that you have for every single record that you have, right? So if you have one row, what is the why or what is the class of that? You can just say it belongs to class of apples because the label is apple. So can you distinguish between class, which is a kind of general thing, and label, which belongs to a record? If yes, please type 3. So just Lucas. I repeat it again. Class is something general, like all the pictures, all the handwritten digits that you have written 3 on them, they belong to class 3. But label is for one specific record, right? So the class associated with a specific sample is called a label. Okay, let's go to a further. So guys, for this specific one, what is the label? Can you please, for the one that I'm pointing, what is the label for this one? Lovely. The label is 0. What is the class that this picture and many other 0 pictures belong to? That's a class of zeros, right? That's the class of zeros that has lots of samples in it. Okay, so the thing is, the major library that we worked with so far was Keras. So we need to set it up. If you work with Anaconda or anything but Google Colab, there is a chance that you need to install it separately. And again, there is a chance that the version that you're dealing with is different from the version that your Python work with. And the version incompatibility is one of the challenges. But the good thing about Colab is everything is already set. So you just need to proceed these commands and everything will be okay. Everybody, would you please open your Colab and type this line from keras.datasets import mnist. And please run it. And if everything works fine, then please type 5. NS, thank you. Let's wait for a couple of more friends to confirm. Atakan, thank you. Okay, those who finished already to use our time. How is the clarity of the monitor, the screen? Is it clear? Okay. Normal. Thank you. Okay, though. So can I ask you, please, write this, or you can copy from the book. Here's the command. You can simply copy this line. The good thing about it is the MNIST dataset is already divided into 4 different categories, 4 different portions, parts. One of them is the train images, and the other one is the train labels. You remember we are talking about 28 by 28 handwritten digits. We have 60,000 of these images. And imagine what? You don't need to do anything. You drag and drop, and it shows that the shape is 60,000. Okay. And how about this one? And if you see that it's a little bit different from, I have to run it again because I have already. Could someone tell add class code? And the train labels, how many labels do we have for that? You may guess. No worries. Okay, I don't know. Let's see. How about test images? How many test images we have for this toy data set? Lovely, Lucas, bravo. We have 10,000. And how many labels could we have for that 10,000 images? It would be the same, right? Because for every single image that you have 1 label. It is very obvious. Guys, how many labels do we have? You said 60,000 for the training one and 10,000 for, yes, Raul, bravo, 10,000 for test labels. Means that for every single sample that we have here, we have 1 label. So label and sample is 1-on-1. But now I ask you another question. How many classes, how many categories do we have for labels? Lovely. So we have 10 classes from 0 to 9, as Lucas said. Huh? But we have 10,000 of those classes. For each sample, we have 1 single label. So you simply load that, and they're gonna just place into these in the iteration that is mentioned. Just let's run it. And then please say train underscore images shape, and it's gonna show you 60,028 by 28 pixels, right? And then you can simply say, what is the length of the labels? As our friend mentioned, we have 60,000 of these labels. For every sample 28 by 28 handwritten digit, we have 1 label technically. The other thing that you could say is say train labels. I'm talking about this part. Train labels, just dot shape. It's going to work like len here. Okay. I'm going to wait. And please, whenever you are done with all these parts, please type 1. Excellent. Thank you very much. And let's just make sure that we didn't miss any part from the book. Okay, let's just go. And now check the train labels. If you check, it's gonna show you something like 5. This is for index 0. 0 for index 1. In other words, guys, the first handwritten digit has something like the first handwritten digit has something like 5. The second one as something like, not that, this, the third handwritten digit index 2 is something like this. And guess what are the indices for these ones? For the last one, it is 59,999, 59,998, and 59,997. And these are the handwritten digits that we have. These are the labels for those handwritten digits. Is it clear? If it is super clear, please type 2. Merci. Okay, now we want to check the same things. Let me just make sure that I have run all of these guys. We want to check the test images shape. So we say, please show me the images shape of the test data set. And it's going to tell you we have 10,028 by 28 pixel pictures or samples, right? And then say len test labels. For every picture, we need to have one label. Again, I repeat that for every single sample, we have one label. So this guy should tell you 10,000. Okay, can I ask you, please, instead of using len, use something else that tells you 10,000. And if you can do that, please just send into my private chat. Again, the question is instead of. Bravo, Stefan. Lovely, yes. Thank you, Lucas. Um, hmm. It works, Yang. You can make it a little bit simplified. Ali, we are missing something here. Okay. Awesome. So, guys, the same as this one, if I simply say lazy, did we run that? No. If we simply say this one dot shape, it's going to show us 10,000 the same way. Huh? Is it clear? So shape is going to tell you it's a vector that you have just labels. Okay. And now if you say, show me the test labels, it is going to show you the handwritten digits labels. I mean, the labels belong to those handwritten digits. For the first one, which if you check the image index 0, it's a kind of 7. Maybe it is something like this. For the next one, maybe it is something like this. You might ask, Reza, can you show the actual? Yes, we are gonna do it tomorrow. But for now, just please accept that these are the labels that they correspond with similar handwritten digits like this one. And these are the last 3, like 9,999, 98, 97 indices. Okay, now it's time for us to get to the next layer, next level, and talk about the model that we want to create, which comprise several layers. Guys, what is the most important thing in deep learning? What is the core fundamental thing in deep learning that makes deep learning deep learning? You can answer in public, please. This is another question, so I want to make sure everybody knows that, those who participate in the class. Okay, have that question and let's just go through the atomic feature representations classifications. Okay, that's a very valid answer, but let's see what books, or what the book tells us. Okay, look at this one. The workflow will be as follows. Guys, what are the things that we are going to do? First, we'll fit the neural network. The training data means that 60,000. And then the trained images and trained labels are going to just find a relationship, right? I'm going to answer, it can handle large data sets. Yes, but we are going to talk about it. I'm happy that you have the question and different answers. We are going to just answer it. Guys, is it clear? We are going to fit our neural network, the training data, which contains train images and train labels. Okay. I do appreciate everyone who participates. Would you please, if you can hear me clearly, type 1? And yes, thank you. Please type 1. And please, everybody, pay attention to this part. Thank you. Appreciate it. The workflow is like that. First, we give the samples, the training images and the labels, and we say, hey, deep learning, that's your homework. Go and find patterns between them, right? Go and find relationship between them. After that, the network will then learn to associate images and labels. And after the network did the job, so now it's time to predict and see how good our model works, right? So now we say that, hey, we ask the network to produce predictions on the test images. This is actually the battlefield that can shows how capable our model is. Before that, it was just a maneuver to say, okay, I got the first batch, the second batch, and so on. But if you want to really test how good your model works, you need to bring it to a real field, and that is test images. The feature for test images is there is no leaking data. Means what? Means you do not include any part of test images in your training process. Otherwise, it's going to be kind of cheating. Means you already have the answer, and that's not that much difficult to guess what could be the label because you already have the answer. And we'll verify whether these predictions match the labels from test labels. Okay, what do we call that? Guys, what do we call the percentage of the labels that are aligned with the actual labels? So means predictions. Okay, Ali, very correct. That's the accuracy. The accuracy shows how many of our Y prime, means the predictions, are aligned with the actual label. Does that make sense? And as Lucas said, the difference between these two means Y prime and Y, the actual label, it creates loss score for us. Okay, what is the function that takes care of loss score? Loss function, that's one name. What about the other name? objective function, Rachel, bravo. What is the last name that in some more recent references you could find? Excellent. Erdal, lovely. Cost function. Yes. Okay, bravo. Amazing. And now it's the time for us to import models and layers. And please pay attention to one fact. And that is, in many of the cases, you see, for instance, there's an update happened in Keras, and the models that you want to import, it doesn't match the rest of the Python that you work with. So you need to go and borrow that from TensorFlow.keras, not directly Keras. It rarely happens. Just be prepared for such cases. One of the to-go things, and why I know that, very simple. It happened to me. It showed error, and I just searched, and I found this in what do we call it? TensorFlow. And Stack Overflow. TensorFlow. So Stack Overflow, I found it, and I kept it. After a while, it turned back to the original format. So everybody, please type from Keras import models, and from Keras import layers. And after that, we are going to create our network. People call it network, people call it model. You can call it whatever you want. It's just a name. So what is this model? The models dot sequential is the type of model that we are going to work with. Do we have any non-sequential model? Yes, we have functional, and we're going to talk about it in next chapter. So because we have different types of models that we can use, and sequential is one of them, we have to mention which one do we want to work with. So network equal to models.sequential means that we are going to add layers into our model. So far, what do we have, guys? Can anybody tell? Let me just give me a second. Look, I said we have models and layers and training data and training set. Ali said, very correct, Lucas. Ali said, we are making the network ready. That's the next step, Ali, correct. And Lucas continued saying that, and selected the model type, which is sequential. Lovely. Anna said, making the neural network. That's the best title we could find for it. Okay. So now, just give me a second, please. Okay. So can you see this paint? If yes, please type 2. Okay. So look at this one. At the moment, we have pictures that they are handwritten digits, and we didn't do anything. So imagine that the first one is 5. And the last thing that we have is, we know that we have some labels, right? And these labels should be what? Should be 0, 1, 2, 3, 4, all the way to 9, right? So we need something here. And that is nothing but our network, our model. We know that we are going to have sequential model. We don't know how many, but we know that we are going to have this layer, which is going to be the entrance. Imagine that we are going to shred these guys and put this into here. And then we are going to have one layer. So this is going to be the input. We are going to have one layer, for example, another layer here. and all the way to the end. So what are these? What are these layers, guys? These two, what do we call them? Excellent. Hidden layers, right? Algor, merci. Bravo. So we have those hidden layers. And just let's get back to where we have left off. And let's go a little bit further. Here you see, it says that we are going to add a layer which is dense, and we are going to talk about what dense layer is, which has 512, and the activation is ReLU, and the input shape is 28 by 28. Aha. That's the first layer. And we are going to add another layer, which is going to have 10 different values. And the activation for that one is not ReLU, it is softmax. Kind of confusing, right? But don't worry. You remember that I asked you a few seconds ago, and I asked, what is the core building block of neural networks? It is just layer. That's the core building block, because you have all the other parts that we deal with in other forms as well. You have, for instance, those input values, you have the labels, but the thing that makes neural network different from the others is having sequential layers, having layers. So the question for you guys, what is the core building block of neural networks? Would you please tell me and make me sure that you can answer the quiz? Lovely. Excellent. And every layer works like what? Thank you, Eric Marco. The layer works like a data processing module that you can think of it as a kind of filter. This is a very nice analogy. It says that some data goes in and it comes out in a more useful form. So we call it a kind of representations. It's a kind of progressive data distillation, and a deep learning model is like a sieve for data processing, made of a succession of increasingly refined data filters that makes it more abstract, close to the labels that we have. Those sieves that we have, those filters that we have, they're nothing but layers, right? Lucas, bravo, excellent. Raul, yes. Like the stellar machine, right? And now the other thing that we mentioned here is they are fully connected. What do you mean, Reza, when you say fully connected? Please look at this one for a sec. Do you see that this one, the first thing that we had, my apologies, the first thing that we had, we had a kind of handwritten digit, and then we brought it to something like, instead of 28 by 28, we brought it to just one column, which is 28 times 28. Does that make sense? So that contains 784 neurons. And this one, the very first one, is what? It's the inputs layer. And now we have for instance, two hidden layers. Guys, in the toy example that we just created, we mentioned just one layer that has 512 neurons. Just we had one hidden layer with that amount of neurons. And what do we have here as we have 10 possible labels, right? These will be our predictions. Guys, if everything is super, super clear so far, please type 1. Fully connected means that each Ali is explaining. I'm reading Ali's sentence. Ali is saying fully connected means that each neuron is dense in the dense layer, receives input from every neurons in the previous layer. That's the kind of question. That's completely true. Look at this one, please. Every single neuron here is connected to all of these guys, right? And every neuron here, they receive the values, as Ali correctly said, from every other previous layers. That's what we call it, fully connected, okay? So Lucas asks, is the 10 output layer is the softmax? Okay, I'm going to talk about it. And 28 by 28 is about taking a 2D array and flattening exactly. That's what we are going to do in no time. But so far, guys, whatever I shared on the screen, is it now clear what is happening? If yes, please type 1. If you have any questions so far for this one, what is the distance, for example, or how they connected, or how we are going to just bring 28 by 28 to that one column. Okay, awesome, lovely. So we call it densely connected. And let's just bring now I see there is something missing. I have to have another laptop so I do not forget which screen is the current screen that you are seeing. Okay. So this is about the fully connected. And now the last important thing for the quiz. I'm sure that we are going to work on it, but tell me, what are the 3 elements? I give you time, please read it yourself and tell me. What are the 3 elements that for compiling a model we need? I read the first. To make the network ready for training, we need to pick 3 more things as part of the compilation steps. What are the 3 fundamental steps in compilation? Okay. Ali, how about reading this paragraph? Thank you, Lucas. Okay, what are the, okay, the question could be, for instance, opposite. What is not among the compilation steps? We know that loss function, optimizer, and metrics to monitor during training and testing. It could be accuracy, it could be precision, and there are lots of things. It could be the for something like linear regression. It could be square error, mean square error, MSE, or it could be absolute error, mean absolute error. But we're going to talk about them. How's loss function different than matrix to monitor? That's a very good question. Let me ask you something, Lucas. Actually, that is something that I had in mind before. Imagine that we are working with you see this screen, right? Okay, imagine that we have something like that's the simplest thing that we can think of as regression. Okay, this is a kind of regression problem. Lucas, can you see that? Okay, awesome. So in here, what is the things that we can measure? This is this amount off from this is this amount off, this is this amount off, this is this amount off, and so on. Does that make sense? So for loss, we are going to calculate the real amount. We have a unit for it. So it could be, for instance, centimeter, or it could be, I don't know, the price, dollar. There is a unit for it. You expect that the price in here is something like 10,000, while you calculated 11,000, right? Is it clear? So in short, loss function provides the actual difference, the mean of actual difference for the current thing, right? The distance to the point, in this example, loss function, just average of distance. Okay, but let me ask you the other thing. Here, what is the accuracy? We are almost 10% off from the correct answer. Is it right? Lucas, asking that question shows that you have read the book thoroughly. So look at this one. In here, you have units like dollar or something, or for instance, centimeter, kilometer. You have a unit when you want to calculate the loss function. Huh? But the matrix that you're going to have is unit free, means that you are 10% off from the expected accuracy. That's a very short, concise answer to it. We are going to elaborate more on that. Okay, look at this one. The loss function in this example, the loss function should calculate what? Can you please tell me what is the output of loss function here for this one? The loss function calculates 1,000, right? And there is a unit for it, which is, for instance, CAD, Canadian dollar. If it is clear, guys, for everybody, loss function, calculating loss function for this one is 1,000. Okay, what actually the label is 11,000. What your linear regression predicted is 10,000. Does that make sense? And the difference between these two, is simply 1,000 Canadian dollar, for example. If it is clear for everybody, please type 1. This is the output of loss function. Just only one person? Okay, thank you. And now tell me, please, tell me, please, if I want to say how accurate my guess is, I see that the actual value is 11,000, and what my linear regression predicted is 10,000, means that I'm almost 10% off. And that 10% is a kind of, there is no unit for it. It shows how off I am from the perfect answer. Does that make sense? So this is what we call it metric. And for this toy example, it is accuracy. Huh? Okay. Lovely. Yes. True. True. Excellent. You're 10% off. Okay, Lucas, that's a very valid question. I hope we just get a kind of general idea, but we are going to extensively work on it in future chapters. For now, yeah, loss function is the exactly, while the metric is a kind of percentage without any unit. Lovely. You got it. Almost you got everything that we wanted. So if you want to get back to the kind of conclusion for what we did here, we said, okay, let's have an optimizer. We have different optimizers. One of them is RAMS prop, RMS prop. The other one is Adam. For loss, we have categorical cross entropy. My apologies, guys. I have forgotten. That's why I said I have forgotten to switch the. Okay. So, guys, can you see the PDF? If that is the case, please type 2. Thank you very much. Okay, so we quickly, merci. Thank you very much. We quickly need to tell the computer, hey, the optimizer is RAMS prop. The loss function is categorical cross entropy. And the matrix for this one is accuracy. But if it was, for instance, linear regression, we had the square error or mean square error. So for the sake of this that we have already covered, everybody please run this line, run these lines. I received that question, what is activation softmax? That would be the last thing before we close the session, but I want you, please, everybody, run this one and then this one to save your time. Oh, those who could finish all the way to this point. Okay. If you could finish running and getting to that point, please type 1. Okay, thank you very much. I received that question because we do not have that much time and I need to start next class pretty soon. I just quickly answer one very fast agile. Look at this one, please. Okay, guys, at the beginning, the weights that we have here are randomly assigned, right? What is the chance? What is the chance that we have here to say it is 0? Imagine that it is 5. It should be 0.1, right? How about the chance of saying 0.1 for the next? So 10% is the chance for each of them. Almost, I'm saying that almost means that for one, it could be 0.8. For the next one, it could be 0.11. For the next one, it could be 0.13. But the chance almost for every one of them at the beginning would be almost 10%. Guys, if it is clear, please type type 2. I'm sorry, because we already have. Lovely. Look at the last thing. If you sum them up, even in the first attempt, the sum of these would be number 1 or 100%. Does that make sense? The overall process should bring us closer and closer to 5. Means after a while, we are going to have for instance 0.60%, 0.6 for this one. This one is 0.05, for example. This one is 0. I don't know, 1, and so on and so forth, right? And still the overall number would be again 1. Is it clear? The softmax is responsible to say which one is the winner of this game. Guys, it's not interesting for us to know that, okay, for example, one is 0.05 and the other. We just want to know the winner. The softmax responsibility is to pick the winner. By saying that, I have already covered everything for the quiz and everything all the way to this part. We have just started the compilation step. So tomorrow we are going to continue our journey. I would be thankful if you just have these lines that we covered. So tomorrow we are not gonna start from a thin air. What I'm gonna do is I'm gonna just bring these lines and share it in the D2L environment, and then you can just download it and we can continue from there if for any reason. I missed the add class. Can anybody, let me just bring it. Okay, so guys, do you see the add class? Okay, 0 B4D. Okay, thank you very much. Have a wonderful one and see you tomorrow. Take care. Ciao. Bye.